Okay, here's an example. If g of x is 6 over x plus 3, we're going to try to graph this. Okay, so look at your notes. Where do vertical asymptotes occur? Okay, so the vertical asymptote is where the denominator equals 0.
Is that what B is?
So 0 equals x plus 3. So what's the vertical asymptote here? Negative 3. So this is the vertical asymptote. I'm going to start to put stuff together. 1, 2, 3. Okay, that's one thing we know. What about a horizontal asymptote? So this guy has, I'm going to put it in blue. This guy doesn't have an x, right? So it's x to the 0.
So it's
And what's this one?
X to the 1.
X to the 1. So
That's
the
bigger.
denominator has a bigger power. What does that mean?
there's no.
Look at your notes. If,
Then that means y equals 0.
Yeah, after Y equals 0.
yep, y equals 0 because the denominator is bigger. So I guess I should put this in a different color.
Okay. I've got this one.
So here are two asymptotes so far. We've got one at -3 and one at 0. And then we have to figure out, we can figure out other things. We're going to test points. Let's figure out what the x-intercept is. That might help. How would I figure out what the x-intercept is? And the y-intercept?
It's where y equals 0.
The x-intercept is where y equals 0. Okay, so let's set, and this is y over here. So where this equals 0. So 0 equals 6 over x plus 3. How would I solve that?
You times it by 6.
When would that be 0?
Don't you have to like solve it?
Yeah.
So don't you times it by 6?
So you multiply this by over here. What does that give us? 0 times x plus 3. If you distribute 0, what do you get? You just get 0. So this will never occur. This doesn't exist. So there's no x-intercept. What about a y-intercept? Y-intercept is where what value equals 0?
X.
Where x equals 0. So y equals 6 over 0 plus 3.
0 plus 3.
Because I plugged in 0.
6 about it, so it's 2.
6 over 3. So this occurs when y is 2. Okay, so we know that there's a y-intercept at 2. How do we graph that?
You would put a dot
Where?
at
Y equals 2.
where y equals 2.
Okay, we know that there's this point here. So we know this is never going to cross here. It's never going to hit 0. But there's an intercept here. So I'm suspicious that this graph looks like this.
Me too.
Yeah, no X.
Very suspicious.
I mean, we knew there couldn't have been an X-intercept because of the asymptote.
Correct. And now we have to figure out what happens over here.
Nothing. Does it,
So
something
what
always have to
values
happen?
are over here? What you can do is test values. So this is -3. Let's test, for instance, 100. What's g of 100? 6 over 100 plus 3. What's that?
It's a lot.
Yeah.
It's very small.
It's a really small decimal. Is it negative?
So,
No.
no.
Okay, so it's a small decimal.
So it doesn't have to be a negative
What about-
number.
That doesn't mean it's negative. It means it's really small. What about like
But we
g
want-
of 5? G of -5.
Negative.
I'm sorry, I meant to do -100. -100 would be a small negative decimal, right?
Yeah.
Oh, yeah.
That's what I was saying. We needed it.
What about g of
2.5.
-5 or something? Something closer. G of
6
-5
divided by
is 6 over -5 plus 3.
Oh, so it's 8. Oh wait, no, it's 2. 6 divided by 2 is 3. Perfect.
So we've got
Negative
3, 4, 5, and -3. here.
What's going on?
We have to figure out what this graph looks like.
So you're just testing all of the
I'm
points?
testing the points. But when I was really far over here, I was really, really negative. Closer to 0. Let's see what I get if I do g to the negative 4.
So 4 plus 3 is 7, 6 divided by,
Remember, it's negative 4 this. So it's 6 over negative 1.
oh yeah, negative.
So it's even more negative. So that means this graph's going like this.
Okay.
And it's going to approach this asymptote.
Okay.